All right, well, as Braden said, I'm here to talk about Google Cloud. First, I sort of want to check the room a little bit. Who's played with any cloud provider or anything from any cloud providers? AWS, Azure, GCP, Rackspace? Okay, about half, a little more. So who's in the room? So like engineers, hands up. Okay, managers. Okay, students. A couple students, awesome. All right, so now that I sort of know who you are, like we've got, students, engineers, now who am I? I'm Thomas, KCCPU on Twitter, Thomas Well on GitHub. I'm an SRE. I'm actually not as much as you might believe. I don't work for Google, used to. But I work for Arbor Networks, aka NetScout, out of Ann Arbor right now. I mean, okay, I live and work in Grand Rapids. The office is in Ann Arbor. Split the difference for here. So I guess, why should you listen to me on GCP? As I said, I was a former Googler. I actually used to work physically closely, but not actually like with the cloud teams up in Seattle, and then I worked in home base in Mountain View, California for a while. I'm also, I've been a consultant specializing in GCP, and I've just been playing with Google Cloud, aka GCP, for a long time. I've professionally been working in GCP for 2.5, 3 years. Probably been using it personally closer to about 5. So, I figure I have, a reasonable idea of how things work. So just an outline, I'm actually going to give you a small sort of high-level intro into GCP. I'm going to actually walk you through an example, or frame this all in the form of an example app. So I wrote an example app using GCP, and it connects with a bunch of different services. And then after I've given you sort of an idea of the app and how things link together, I'll actually walk you through some of those services that the app uses in GCP, and then I'll open the floor to questions at the end. So GCP, aka Google Cloud Platform. Thank you, Google Assistant, for triggering. So, what is it? It's Google's cloud offering. It's kind of like AWS, Amazon's AWS or Microsoft's Azure. It is a very large, usable cloud platform, cloud offering. I'd say it's versatile. Like, if you have a job that you need done, you can do it in Google Cloud. It's fast. I'll actually show you later how fast spinning up an instance is. I've been really happy with it as compared to AWS, where you click it, you go get a coffee. So you'll see how fast it is, and it's compliant. And by that I mean, I just went through a selection of their compliance site. So it's got HIPAA compliance, FedRAMP moderate, working on high for those of you in the Fed space, GDPR compliant, obviously, and then it's got, I just grabbed a couple others. So they've got a compliance website, cloud.google.com/security/compliance. I'll send out the slides later, so you don't have to worry about that. But if you're in a space that needs any sort of forget what the word is, any sort of documentation that states that the provider you're working with is compliant with various things, they have it for you. And then I walked through those points already, but when I say versatile, they've got a lot of stuff. And I mean a lot of stuff. These are all, you probably can't even read that. Yeah, so this is their 4-word cheat sheet. So each of these is a product, and it's related to at most 4 words, what it means or what it does. So App Engine is managed app platform. Carrier peering is peer through a carrier, cloud data transfer is data migration tools / CLI. And it's just each line is a different product under the cloud umbrella. And I just like to show this because, this is something Google, like their developer advocates put out. And it just shows the sheer amount of stuff. And this is updated as of, 3 weeks ago? And if I remember correctly, there's at least one thing they've released since then that isn't on here. Like they send out weekly product updates with, hey, this is what we're trying, or this is what's in alpha, this is what's in beta, this is what's generally available. And, you have to read the emails to keep up with every new thing they're doing. That's not to say that it's hard to keep up with what they do. Like, if you have a certain list of things you're going to use, like, that's your list. They're pretty much not going to change. But, like, if you have something else on the list that you want to use, like, it's there. So I said I've got an example app. So, yeah, so say you're a plucky little startup who wants to take on YouTube. You've got an idea, you've got some people, you've got backing, you just need to do it and you need to do it quickly. So, like, you have a couple of engineers, developers, you don't really have, like, ops people, you just need to get it done and, like, get an MVP out there, right? So this is sort of the thing you come up with, like, you've got, your internet out here, and then you're going to have, like, a little Nginx thing right here, sort of load balance things, and then, because your people know Ruby, you're going to write it in Ruby, it'll be, quick enough to put out there, and then you need like some sort of SQL database and some sort of blob store, right? So pretty simple app, right? So this is what it looks like once you've played around with it a little bit. So I've been tinkering with this, but like, okay, you've got so when you throw it out there, you've got like your SQL store down here, so Google Cloud SQL. You've got your cloud storage, which is Google Cloud's blob storage. And I'm using, because I know Kubernetes, I put Kubernetes in the middle of it. So I'm hosting the actual app code on Kubernetes. Now you can swap out any of these things. And the rest of this is like stack driver for logging, load balancer for load balancing products into and out of Kubernetes. You can turn on a CDN if you want. And then I've actually, because I wanted to, because you want to be that fast team, this is a deploy pipeline. So, you've got your local laptop here, your dev laptop, goes up to GitHub, up to cloud build, and then pushes the stuff into container registry. And because you're so fast, you want it to, if the build passes, you just want to throw it out there, right? So cloud build puts your artifacts in the container registry and then tells Kubernetes, hey, here's the new stuff. Go pull it in. And you've got your KMS because you've got your like SQL access tokens or SQL access keys that you want to put into GitHub or into the GitHub repo, but you don't want anybody looking at other than the people that are allowed to look at it. And so this is what it sort of ends up looking like. You can cut half of this stuff out for your MVP. This is just what I did because I wanted to sort of show things off. So with that, let's see what that looks like in the actual console itself. So GCP, when you first go to the console, this is where you land when you want to manage your applications, right? It's pretty customizable. All these things are movable. This is just sort of the default layout, so it gives you like your project info. It gives you a summary of your resources down here. So like I've got 2 compute instances, 6 storage buckets, an App Engine app, and then SQL. And you You can have all sorts of graphs of like, this is what CPU looks like on your compute engine. And then one thing I really like is the status bar right there. So as soon as you log in, you get your status up there. Right now, it's green, but say something's gone a little wonky. Like, every cloud provider has their bad days, right? So, you get your page and it says something's offline or some, performance is degraded. You can, as you would log into the console to look at your dashboards or whatever you're going to look at, there's your status right there. And you can say, oh, okay, my provider is just having a little bit of latency problems on this one thing that I use. Or, you can help funnel down any sort of problem based on that thing, which you'd run past in your normal flow of operational investigation. So let's say you're setting all this fun stuff up. You don't want to do any of the fancy stuff I did. You just want a compute instance. You're going to host everything on that. That's going to be your first deliverable, right? So you go down here. As I sort of just flew through it, but the navigation pane is there, and you've got all of this stuff. All of those are product categories, and in previous iterations of this talk, I've tried to hit every one of those. And then the list got too big, and I couldn't do it without losing people. So in here, you would go to compute engine because you just want one compute instance, right? So, sorry, my laptop's working a little hard, but you go in here and you just want a compute instance. You can see I've got a couple running, or I've got one running, one stopped. You go up here to create instance, and you get this nice little dashboard. You can call it whatever you want. You can pick where you want it stored. These are analogous to AWS regions. So I'm just going to do, where to go? I'm going to do Iowa because that's the closest to here. I've also tested previously like latency between me and various GCP locations. Iowa is the fastest by about 10 milliseconds. Not that it really matters, but and then you can pick your zone. This is analogous to AWS's availability zones. I'm just going to do US Central 1A. And then you pick your type of instance. So they've got general purpose and then memory optimized. The memory optimized instances are kind of big. Like the one it defaults to is 96 core, 1.4 terabytes of RAM. Is big. But like, let's go back to general purpose because ain't nobody need that for your first MVP. So you can go in here and they've got some templates. So it defaults to N1 standard, which is one CPU, one core, 3.75 gigs of RAM. And you can go all the way up in here to like 160 CPU, 3.75 terabytes of RAM. Like these are huge. Or you can go down to like an F1 micro. Let's go to an N1 standard. Also, you can just pick a custom, and then you've got sliders of like how many CPU you want and how much RAM you want. But let's just go an N1 standard. Not really. Disk speed is based on, I'll actually touch on that a second. Yeah, it does impact network speed. Much like AWS, network speed is capped based on the number of CPU you have. Yeah. Between the generations? Oh, these are, Honestly, I'm not sure. That appeared like this week. I suspect they're working on releasing a second generation. There's been some talk in the forums about a new generation of CPU coming out, so that could be what that is. I don't see a toggle on it right now. Yeah. Actually, I wonder. That could be. Let's pick C. Oh, yeah. So if I go to Iowa US 1C, or Central 1C, actually compute optimized showed up with more CPU focused, and those are second generation Cascade Lake. Okay, good catch. Let's not do the expensive one, please. All right. And then if you want, you can pick your platform under advanced options, like pick your CPU platform. And then add GPUs if you need a dedicated. So they've got the Tesla K80s, P100s, P4s, and V100s. So if you're doing a GPU style compute job, you can pick that if you need. Let's see. You can also turn on an actual display. So it'll give you some sort of screen capture capability. You can sort of do that, it'll, by default, it'll install some sort of CLI-based operating system, and you can install X and do things like that. This will give you sort of more capabilities on that end. And then down here, you pick your operating system. So they've got all sorts of stuff. So Debian, CentOS, CoreOS, Ubuntu, container optimized stuff, Red Hat, SUSE Linux, and yes, they even do have Windows. So, and the fun thing about that is they will actually do the licensing for you. So if any of these if you pick an operating system that has a licensing model attached, they'll take care of the monthly licensing. It'll become a monthly fee as opposed to whatever volume license or per seat license you're usually used to with on-prem stuff. And then there's just so many more things. And you can also upload customized stuff. So if you've got a custom build of some operating system that you want to just stamp across everything, you can upload that and make use of that. And you can also build a machine up there, take a snapshot of it, build another machine based off of it, or just pick a running machine and say, I want a clone of that. And it'll do it. So I'm just going to pick, because I'm used to it, Ubuntu. And down here, you pick your disk type. So this is where your IOPS would come into it. They've got standard Winchester spinning disk hard drives as well as SSD. I'm going to pick SSD, and then 100 gigs. You pick, here you would pick your access control. So you can say whatever job is running on this machine, give it access to everything in my cloud or in my in my virtual cloud network, or you can select specific access for it, some subset of there. By default, they have network tags that just say allow HTTP traffic, allow HTTPS traffic in case you're running a web server, which we would be actually in this case, because remember we're putting up test tube, our rendition of YouTube. And then, you can, I expanded the more options thing. So you can there's all sorts of options like enable delete protection, do any sort of reservations attached. So if you have extended, dedicated reservations, I forget what it's called on AWS, where you say, I need one computer of this size for an entire year, you'll get a discount based off of that, and you can say this is that machine. Reserved instances, thank you. Specify a startup script, and there's just so much more here. One nice thing is no host at Google stays running for more than 10 weeks at a time, but you'd never notice because they have live VM migration. As far as I've seen, yeah. Yeah, I actually had, oh yeah, there's always that one. Actually, I had one machine that could tell that a live migration had happened, and the only way we could tell was that like the wiki product that was running on it at the time would kind of crash, and we never really figured out why, like what was weird about it. But we would just go back in the logs and see, oh, there was a host migration event. Okay, that's why the wiki's no longer online. Fortunately, it was an internal product, so like we didn't really care. It was just like, oh, okay, restart the job. And you know, there's so much more. Like, you can turn on a TPM. So like, if you've got jobs that are based around some sort of I forget what it stands for, but like, you know, you've got like machine certificates that need to be stored on machines, something like secure credentials that need to be stored on the machine. You can use that mechanism. Additional disks, more networking. You can set up sole tenancy, so if you have a special arrangement with GCP to where that host is only me, that's how you do it. Then you could click create. Okay, so we recreated one core 3.75 gigs of RAM. And you know, that create was, I clicked create, so it's now going out, provisioning the machine, finding some place for it to go. It's already up. I can't even put out the full description of what it's doing. So the machine is now online. It has a public IP address, and you notice it's clickable here, so I can just click it. Nothing will load because there's no services running on the thing yet. But it's got an internal IP. You can see like what zone it's in right there. You'll notice far right, there's an SSH button, right? So this is an Ubuntu machine. So you'd normally SSH into it. I click SSH, I get a window. It is currently provisioning SSH keys, like generating a new key pair, giving one end to me here in the browser, and giving the other end to my machine. And there we go. I have an SSH window live here in front of you. And like, you know, it's a Linux machine, you know, it's got apt-get. It's a full-on machine. It's a full-on CLI here in the browser, which I find really nice. Just because I can, like, if I'm off somewhere, like I don't have VPN access or whatever, I'm in a coffee shop, I get a page, I need to look at something in browser. Doesn't even matter what machine I'm on. Like, not that I trust my credentials to the random computer at the library, but like I could go to the one in the library, sign on, and like go to SSH, and then you know log off and change my password. But but like that's the flexibility you get. And they actually have an app for like Android. I assume there's one for iOS as well, where you can pull up SSH from your phone. So you know, in the middle of a parking lot somewhere, you can pull out SSH and check something. I wouldn't recommend doing it for rapid response because SSH commands on a phone suck, but you know, it's there. Okay, so let's close that out. We don't really need that. But like, you know, for our little test tube, that's perfect, right? We have a machine. It happened right here. It took me less than 5 minutes to provision a machine. It's public, it's on the internet. I can do whatever I want. I can give it to my devs. But let's say you're moving into Docker, right? So you want that, or actually no, let's talk about the storages first. So as we said before, you know, we need some sort of SQL device and we need some sort of blob store, right? You know, you've been running it on this single machine, but like, you know, you're gonna, at some point you're gonna run out of storage on this one machine. Performance is kind of sucky. So you pull out SQL, right? GCP has here under SQL, just, you know, hosted SQL instances. Right now, they give you, the options are MySQL and PostgreSQL, Postgres SQL, PostgreSQL. I'm not really in that community, so I don't really know how to pronounce it. Yeah, yeah, everyone's got a different one, right? I'm sure there's an official, but so these are the two options you get. It's two options of each. So MySQL is 5.6 and 5.7. Postgres is 9.6.11. If you're a Windows shop and you need SQL Server, it is recommended that you build your own instance. You go back to the instance console and create them. They actually have templates for SQL Server. So you just pick one of those templates and it'll stand it up for you. It's just not the same style of SQL hosted instance. You end up doing the management on your side. But I've got a pre-existing instance. So, you log into the console or you log into like the instance and you can see, you've got your dashboard right here. And every instance you go to, every machine you click through, that sort of app engine thing, SQL instance you click through, you get a dashboard. And it's really nice because you can see CPU utilization, storage utilization, memory, read-write ops, ingress and outgress bytes, in this case, SQL queries and questions, in InnoDB pages, active connections, and you can scale it up to 30 days. This instance hasn't been alive that long, but you can sort of get an idea of what's going on just from here. And there's all sorts of you can create users and databases straight from here. You can trigger backups. You can set up a backup schedule. You can set up replicas. And actually, if you go to the operations tab, there's an operations log of everything that happened to the instance. So you can see there were backups that were triggered, there were updates that ran. And actually, I haven't really showed this yet. So every GCP project that you have this little button up here, Interactive Cloud Shell. You click it, you get shell. Takes a second. It doesn't have a lot of storage, but it's enough to run some stuff. So you can put some small Git repos in there. You can put scripts in there. You can do API calls directly from there. You don't need to have a debug machine live. You can do your debugging from here. And actually, if I close out of it, you can actually, a lot of the commands that you would run have a connect to or run from Cloud Shell. So if I click there, it does the IP whitelisting and all of the security negotiations that would happen that you would need to do anyway to get access. So it's just doing that live. I'm not actually going to do that because I would need to pull up the root password for this instance, which is something I can't remember and I don't want on the recording. Right? I've totally never done that before, and then I had to roll all the passwords. And let's see, and forget, it's somewhere in here. You can set up you can set up so master-slave replicas. So say, as test2 builds out, you've got more people using it, not a lot of write operations, but a lot of read operations. You can scale that out to a lot of read replicas and still have your one write master. I know on Postgres, it doesn't do auto load balancing, but there are libraries out there that you can use to say all read goes, amongst these machines, all write goes here, that sort of thing. And then, as more people upload videos, this one little machine. Yeah.
How dynamic is that?
Like with respect to the SQL instances or just machines in general?
More so the sequence.
There is, let's see, under edit, let's see, it's a little hard, there we go. Under edit, on any of the instances, you can change their provision. So as you grow up, or as you grow your product out, you can say, I need more CPU, I need more RAM. It will require a machine reboot to do that, but you can add more resources with minimal. You don't have to create a new instance and migrate all the data over and then shut down the old one.
If you go up and you realize too far.
Yeah, and actually, let's see, I can actually show you. On the compute engine page, none of my instances here have it, but let's go here. Get rid of the side panel, please. So this is a client I have, and this is their production environment. You'll notice there's actually an increased performance recommendation. This is GCP saying, hey, you're riding this machine pretty hard. I'm going to make a size recommendation to upsize it. And you can actually click apply, it'll reboot the machine and apply it. And similarly, they'll make a recommendation if your machines are underutilized and say, hey, you could save money by downsizing from here to there. Click to apply. I haven't seen it. I think this is one of those times, because it's a change to your billing, I think they want it to be an explicit action on your part.
If you do this, can you say scale between 5 and 12
Yeah. Yeah, you can set up instance groups and then say, hey, based on X metric, scale up or down within this range of machine number. Yeah. Let's see. Okay, so any other questions about instance sizing, SQL, before I move on to storage? Okay. So there are a lot of storage options. As with everything, I'm going to pick the one that I would use in the case of test tube. We just need a blob store, right? There's, there's big table, there's data store, there's fire store, file store, there's SQL, Spanner, memory store. One note, if you're going to play with Spanner, Spanner is the horizontally scaling one. A lot of power there, but it is not budget friendly. Don't use Spanner unless you have to. If you're just playing with it in your off hours, be really careful because it gets expensive quickly. Because you're spinning up like 5 or 10 or 20 SQL machines effectively, and each one of them is costing you money. But yeah, there's I think data store is the NoSQL version, big tables is the big data storage. We're just going to go with plain old blob store, right? So I've got a bucket. It's just like an AWS CC2 or S3 bucket. It has the same API actions, the same interactions with stuff like that. And it's a file store. You click through, it's got your stuff, and you can see there's files there, right? So let's go ahead and see what we've built so far, right? We've got an instance running, we've got SQL backend, we've got storage. And as Chrome is deciding to be annoying, it's saying the site isn't secure. It actually is, it's just caching old information. I have, in fact, valid certificates. It's just Chrome being annoying. So, this is what test tube looks like, right? This is a video list. You've got an upload button, pretty simple. let's go. Let's just upload a video. Quick little video called Oceans. It's a little test video I like. So right now, I am uploading to my little instance in the cloud, and actually it would seem like my Wi-Fi is not being very speedy because we're only passing 25% now. So what it would have done had I not killed it would send the file up to my app server through Nginx, and then my app server sent it off to the file store, as we showed in the diagram. And let's just click one, and you can see it's just playing the video. So the fun thing about this is I only had to deal with the file store or the file handling on its way up. I ran it through my app store, or I ran it through my app server, and it did a little bit of processing and then put it in the file store. This video is actually serving direct from Google Cloud, or from the Google Cloud Storage. By default, all objects are locked down to API users only. And actually, you can lock it down to nothing if you want, but it's default secure. Each time I upload a video, I actually have to take the explicit action in my app code saying, hey, give me a public URL. Yes, really, give me a public URL. And then I store that and I serve that out to the front end. So by default, you won't end up with the same sort of S3 buckets open to the world sort of thing that you might end up with in AWS if you're not careful. Because actually, if you go in here, you'll see each of these objects is public, but it has a little warning symbol saying, hey, this is public. Did you really mean that? And it's saying public versus the object level permissions, like, you can click it. But okay, so we've got, as test tube, we're one instance, right? Sooner or later, that one machine, not going to do so hot. So we go with what my favorite thing is Kubernetes. Kubernetes on GCP is really strong, like a really strong offering, the best I've seen amongst the clouds. With AWS, you have to have a Terraform script, or you do the 35-step thing they have on their website as to standing up a cluster, doing key exchange, all that. Here, it's the same sort of thing as you would do to create an instance. You go through, you give it a name, you tell it where to store, what Kubernetes version, how many instances, and you just do it. And I should note, down at the bottom of all these create pages, and actually at the bottom of a lot of action pages, there are two buttons where it gives you the equivalent REST call and the equivalent CLI command. So you click it, and that is the CLI command that I would run from my CLI if I wanted to do the same thing I'm doing in the UI right now. And you can actually click Run in Cloud Shell, and it'll pop up the Cloud Shell and run the command. Similarly, it'll tell you what HTTP action to take, what endpoint to send it at, in this case a post. So a post at that endpoint, and then the body of the REST call. So you get an example right here. I mean, granted, their libraries are actually quite good across a lot of languages. I use it in Python and Go and Ruby a lot. But here is the bare call if you need to construct the object in your app code. Let's not create a new cluster because I have a cluster running. Actually, who here has used Kubernetes, know what Kubernetes is? Okay. So for those that know, it's kind of job management across clusters. So you say, I have a job, I have a compute job of some sort, I've put it in a Docker container, and then you just hand it to Kubernetes and you tell it how many instances you need or how many replicas you need, and other rules, and Kubernetes just deals with it. You give it, a pile of compute nodes, pile of machines, and it just figures out a machine that's available and puts the job on and deals with like failure cases and a lot of stuff like that. So I like it because I use it all the time. And similarly to everything else, here's your dashboard of your one cluster. You've got details here. You've got your node pools at the bottom. It's sorry, what?
How are you built?
They bill. The rates are listed in hourly, but they bill by second. I've actually been really happy with that because I know on AWS it used to be you started up an instance and you were billed for an hour. And until you hit the next hour, then you were billed for another hour, so on and so forth. They amortize the hourly cost down to the second and bill you based on that. So it's very truly as you need it.
And I'm assuming you can be honest about that.
Mm-hmm.
You can start with 3 and then CPU goes up around.
Yeah.
8%.
Yep. Yeah, there's a lot of stuff like that. They actually give you, I forget what they call it, but the longer you have the machine running, the more of a discount you're given. So if you run an instance for a full month, I think it's a 20 or 30% discount of the total cost. So it is to your benefit to figure out how to keep jobs running for longer, like compact what things you have onto a certain number of machines and keep them running for longer. But yeah, you can spin things up and down and you're given the per minute basically cost.
They don't have a way that you can calculate the
They don't really have a calculator based on that. There is a calculator page that you put in your stuff, like how many jobs or how many machines of what size and everything, and it'll come out with a total. But there's not any sort of like compute recommendations based on my history.
This is what you ran away at month. If you would have just kept 5, cheaper.
That would be a great thing that I would love for them to make, but is not something that exists. They do give you the recommendations of like you're running the machine too hard or not hard enough and scale based on that, but there's not any sort of like you scaled up these machines and down those machines. You could figure out how to shift jobs. If you put all your workloads into a Kubernetes cluster, things would sort of work out to where, like, as you spun more jobs up, it'll spin more instances as it needs to, but it would compact a little bit more.
I was just wondering if they do really simple, like, real burst in traffic.
Mm-hmm.
If you were having a good burst, so let's say from 3 to 12, and back down to 3,
Mm-hmm.
it might be a point where it's cheaper just to keep 6 of them online.
Oh, right, yeah.
Because your burst got the 6 often enough where you get that long-term discount.
Yeah, there isn't, I don't think their recommendations take that into account, but you'd be able to see based on, you'd have to look in the dashboards and figure it out, yeah. So I've gone through sort of the base level compute jobs that I'm using. So one of the things I really like is, as I mentioned, I have a build pipeline, right? I commit to master, it does a thing. I do that via Cloud Build, which is, it's very much, it's basically, cloud-based shell script. You give it a number of steps and it does things in that order. There is no sort of like branching, but like my jobs, like the builds I have right now, it automatically watches a GitHub repository, public or private. You can give it access, like API credential keys to access. And for mine, it pulls it in, it decrypts my secret files, it builds a couple of Docker instances, it tags them, it pushes them. to to the container registry, which is their cloud registry for hosting container images, and then it runs Helm. Helm is just a package management system for Kubernetes. It's what I use to interact with the cluster and run jobs. And so you've got your up at the bottom, you've got your init steps, you've got your build steps here, and then here you could insert like a test bank. So as long as it returns exit 0 based on a test, your test succeeding, it'll continue on to the next step. So you could have your tests run right here, and then turn 1 if it 1 or non-zero if it failed, 0 if it succeeded, and then it would continue on your deploy steps. That's how I use it. That's how TestTube uses it. You just deploy to master and it gets up there, right?
Can you add manual steps in there?
No, you specify them. Cloud build.
Right. Like I'm imagining like a longer pipeline where it automatically goes to one environment. Let's say you've got one namespace that you deploy to automatically, and then
right.
There's some exploratory manual testing, and then there's sign off, and then there's another namespace, or it's a different environment.
There isn't a way to build that into Cloud Build, but a former client of mine worked around it this way, where they would have master automatically deployed to a test environment. And then during that, it would get tagged with the git commit hash. So when it was approved out of test, they would tag whatever commit that was with like stage deploy or stage date in their case. And they would push that tag up, and there'd be another Cloud Build job watching for that tag, and it'd take the commit hash, grab that from the container registry. So you've got your pre-built artifacts that you're not going to build again. You've already tested them, and then it would deploy into stage. And then they would do a similar thing for deploying to prod based on like a prod tag. So that's how they did the sort of approval. There are other ways to do it, like trigger jobs based on API calls. This would forget what it's called. Spinnaker? Yeah, environment management. I think that's by Netflix. Yeah, but that's one. But it's like added on, not built into GCP. Yeah, and you would specify like your cloud build steps in a YAML file, where like I've got like the decrypt stuff, and then like Docker build steps, and then Helm, so my deploy stage is down there. And it's very much this step, then that step, then that step, then that step. Let me make sure I've... Right? Yeah, just smash a beta tag, ship it out. If you, like in Kubernetes and a bunch of other stuff, and actually like in App Engine, you can do the like in this environment and then scale it based on, give it like 5% or 10% global traffic and then scale it up and down or like back it off. There's actually somewhere in the load balancer, there's a nice graphic of like, this is this is where your traffic's coming from. So like US or like Americas, EMEA, Europe, Asia Pacific regions, and like going to these jobs, and it sort of break it out. Unfortunately, it's like 4 layers down in a menu somewhere, and I can never remember where it is until I stumble upon it, and it's like, oh, hey, that's where that is. But yeah, things move around a lot. Usually they stay the same, but like, they're constantly deploying new stuff. And actually, with this menu being so long, you'll notice I've got some stuff down here there's like custom pinning, so you can say, I'm going to be in Kubernetes a lot. I want that pinned to the top. So you do. I do, before I open up to questions, I want to show, or like more formally open up to questions. Like I'll take popcorn questions as much as you want. Stackdriver is their monitoring solution. It was an acquisition from a couple years ago, so it sort of acts like a separate console, but a lot of things, like there's a very tight integration. It just happens to load up in a slightly different thing. So if you're in an environment where you need to whitelist domain names, stackdriver.com needs to be on your whitelist. And it has all sorts of like, you set up alerting rules, uptime checks. Uptime checks are literally just ping checks, or like your port 80 returned a 200 HTTP code, like that sort of thing. And you can set up custom dashboards. Like I set up a dashboard, and it's a little noisy, but like these are based on my containers, like my app containers in Kubernetes. This is their memory usage, and this is like their CPU usage. So like you can see, like, okay, my Ruby jobs don't use a lot of stuff because they're normally very quiet. So like the biggest thing is like the management, like the container management, and then there's like, it probably is buried down here somewhere. I'm not going to dig it out, but just the code's the like actual container itself. Being that I don't have a lot of load, like it's just the like server maintenance jobs running. And similarly over here. But like if you had a very busy system, you'd see like your memory usage spiking up and down, you see your CPU going up and down based on what's doing anything.
Is this free?
Yeah. Yeah. If you want any sort of alerting, you have to set that up, but like monitoring, like I literally, like these are just default things, like their metrics explorer, if you go into it, it has all these pre-built stuff. So like I want to see VM instances and CPU usage, and there's a graph of CPU usage, and it's on. I didn't have to pay for it. They have a pay level, which is like more history and like more log retention, but that's about it.
Is there like
I don't actually know. I've never used it. Stackdriver is nice to a point. It has, I don't want to just say rah Google or whatever. Like Stackdriver, it always feels like a redheaded stepchild. It gives you some stuff, but like it's not very versatile. So like use it until you get something better. I use Prometheus and Grafana. And one thing I like is their error reporting. Of course, nothing I have has any errors. Let's go over to that client again. It'll watch your logs for new events and pop up and say, hey, there's been this traceback that's occurred, 244 times. And you can click through, or like, failed to decode param on a URL error, and it'll give you the stack trace, and you can see when it's happened. You can click through to the logs, and actually clicking through to the logs is a good way to show off the actual log capture. So this will show you, since I clicked through from the log event, it'll show you the instance of where that stack trace occurred, and then you can click through. Expand it out, you can see it. You can say show in resource context. So it'll say, okay, here's your event, and here's all the stuff that happened around it, which is kind of nice if you're trying to debug stuff. And then So just for like container logs, so by default, Kubernetes stuff will get logged out to Stackdriver, as well as any of like your cloud build stuff, SQL stuff, like rules, any of the like hosted stuff will get logged out to here. And then you can just say, in my case, I'm going in my Kubernetes cluster. I want to look at the app namespace. Let's see, unpin the thing. There we go. So you can see like my Nginx is logging out HTTP requests. And you can actually say, okay, you can hit play and you can see it'll like track it live like a log tail. And it'll just wait there spinning at the bottom for more stuff to scroll up. Kind of nice when you're trying to track stuff down. Right. And as far as that goes, that is, there's a lot more stuff I could cover, but like, you know, it'd be better for you to explore in your own time to sort of figure everything out, because they've got all sorts of big data stuff and like AI and big data, and you know, we could be here for days, and you know, nobody wants that. Nobody wants to listen to my voice for that long. So I'm going to open it up to questions. Any questions you have, like about GCP, about things I've done, whatever. Mm-hmm. Mm-hmm.
How business friendly Azure is, and then there's Google, which seems to be like another strong technically, and some pieces of don't know what really is the true draw.
The draw is, I mean, they are competitive on price, and a lot of times unfortunately, it'll be like the recommendation of like the consultancy I'm working with or my recommendation. Like their UI is, I think, very ergonomic. It might be because I was part of the UX tests, but like I've always found the UI to be very helpful, to be like at like surfacing errors and issues, and just whenever I try to get things done, it doesn't stand in my way. Whereas like with AWS, I always feel like I'm sort of piecing things together. I mean, like every cloud provider has their strengths and like their pros and their cons. I just feel like GCP has a nicer development feel, and if you can make that case to upper management, that usually helps out as far as like, hey, this will save us X amount of hours with our developers having to figure things out. Yeah, that's normally how I would make the case, is ease of use for the developers and ops team.
Okay.
Yeah. And also like speed of response, so like scaling instances up and down is very fast. So
I had a question about organizing as well as visualizing cost.
mm-hmm.
Like, do you have the ability to kind of divvy up, like kind of by team, have organizational structures where you see, yeah, this group is using this much money in their resources, and this group is using this much money, so you can kind of budget that type of thing, and how would you suggest kind of organizing resources?
It sort of depends on how interconnected your teamwork is. So if the teams and their work are very disparate, like they make sort of occasional calls, but like there's very clear delineations, I would just put them in separate GCP projects, and then you can set up some sort of peering relationship between those two. Or between those many. It gets a little hairy because one client I had like 50 projects, and there was one core routing project, so everything had to peer with that, and it was a little hairy. But it sort of depends on how your organization is. If there's a lot more interconnected work, like your teams are bouncing around within the same projects, I would put things together and add billing tags to the resources they're using, and then those would get surfaced through the financial, like the billing consoles.
Is there any way to enforce that people actually use tags or?
I haven't really delved that far into it to be able to tell you. At the very least, I'm sure there would be a way to look at all the resources that aren't tagged, and then you could say, okay, everybody with this stuff, put tags on your things, please.
Yeah. So it sounds like you're saying there'd be, so like for you, there's like your account, subscription, whatever, and then under that you can have however many projects you want, and communication between projects is perhaps limited to a certain degree unless you configure it.
Yeah.
And then tags within the projects can kind of organize.
Yeah. So I know on AWS, sorry, I don't use Azure a whole lot, so like a lot of my other cloud analogies are on AWS. On AWS, you would probably have like a master project and then like child projects based off of that, and however your auth structure works. On GCP, you can set up an organization, and then you can spin projects out of that. And then you can enforce certain rules and auth quite easily from the organizational level. Yeah, but yeah, each GCP project is pretty much, unless you set up a peering relationship, they are effectively their own self-contained network with firewalls and everything. So, yeah. Yeah.
What's the equivalent thing of ARM template or CloudFormation?
CloudFormation is the, I just want to make sure my understanding is correct. It's like a scripted, I need these things, and it does it.
Yeah, I mean, it's declarative,
Mm-hmm.
right? So it's like Terraform, but
Yeah.
that one's AWS specific. ARM templates are Azure specific.
Never actually used them. I've always used Terraform.
That's fine.
Yeah, that's probably the recommended solution because Terraform's documentation is actually really good. GCP's documentation has gotten a lot better, but starting off it was pretty bad actually. It is a lot better now than it used to be. Yeah.
If you were to go strictly, GCP native stuff, it's going to be just like the CLI.
It would be CLI unless, I mean, okay, you saw the list of things in there. So it's probably, I have a feeling that there's something in here that I just haven't seen. But then again, I feel like I would have used it at some point. Yeah, like there's deployment managers. That's probably how you do it. Yeah, so I didn't even touch on this, but there's like a whole marketplace of pre-built solutions, and then you like one-click deploys. So like if you need an F5 load balancer, you go in there and you click it, and it'll give you like, this is your monthly cost. And you click go, and it provisions it. I would assume it'd be via the deployment manager, but I've always just used Terraform because I've always had to sort of straddle between clouds. Yeah.
What's your current role in the project? What's your day-to-day?
I had a very recent job change. I'm working with Arbor Networks who actually do like deployed appliances to like internet service providers and things like that. Up until 3 months ago, I was a consultant working in GCP and AWS for multiple clients, and we were in sort of an advisory and implementation role. So I would make recommendations to the client based on their needs, and then work with them to fulfill those needs in the cloud provider of their choice, with my recommendation being GCP, but you got to do what the client's organizational needs are. So that's what it was until very recently. Originally, and then I moved into more of I was a W-2 employee for a consultancy. So that's how I got. Yeah.
So,
expenditures at Google when you worked there?
No, I was sort of the internal, like, you have a problem, I make the problem go away, hopefully fixing it guy. You know, ostensibly, I was an IT support technician, but like, I wasn't limited to fixing laptops. There was one time where like someone from Gmail came to ask me a couple of questions about how their production environment worked, and it was kind of weird because of someone from Gmail asking me. But you know, like my role was very much like, you have a problem, I make the problem go away. I've since moved into a lot more like cloud focused roles. Yeah.
In your diagram of like the Kubernetes deployment, you had load balancers.
Mm-hmm.
Do some of the other offerings how much load balancing built in? Or do you always have to have that as a buildable feature?
It is built into Kubernetes engine, but everything else, it's very easy to spin up, but it's a manual action. So like if you have instance groups and you have a bunch of, you know, job or a bunch of machines doing roughly the same thing where you need to load balance them, you just you declare, or you create a load balancer and say the instance group is my backend, and do it like that.
What ingest egress terms?
Um. Uh,
No, okay, so,
the let's see. I know the where is it? The pricing is a lot easier to understand than like AWS, but there's been some recent news about AWS like being a little weird in how they charge things. Oh, hey, and they've changed their usage pricing since. But so this is a pricing chart, and it's based on like, this is 1 to 10 terabytes, 10 to 150, 150 to 500 terabytes, and like source destination going from North America, within North America or within the EU is this pricing. Intercontinental, there's that looks to be, is that per? Egress pricing is per gigabyte, so it's the 12 cents, somewhere between 8 and 12 cents per gigabyte for intercontinental traffic, and like that is for premium tier. So they have two tiers of network where premium tier is you transit across the Google network in its entirety between regions, or in the case of going to like an end client or like an end user, it would transit as far as it can within the Google network. Standard is it just transits to the public internet a lot sooner. As far as like it would get onto public internet and then peer across to wherever your end user is. Standard tier, if I remember correctly, is like if you have two regions you need to transit between, it would go across Google's network unless the Google network is heavily loaded, at which point it would end up going through like an external peering relationship as opposed to direct transit, whereas premium traffic goes across the Google network in its entirety. But it's fairly comparable, and I think it's a lot easier to understand than AWS, at the very least.
The whole communication between the Kubernetes cluster and
That is within network, I believe that's free. I mean, they're right next to each other in this case, so they're within the same data center, and that transit's free.
So, from like in the same data center, it should be. So that like various apps and databases all the same data center, they're interconnected constantly.
Mm-hmm.
So if I'm going between like east and west coast type traffic.
Yeah, that would be.
That would
I believe so, yes. I always recommend having your apps and your databases close to each other anyway, but you know.
Well, like a replica.
Yeah.
One you replicate
Well, yeah, that makes sense. Yeah. I believe so. They do also, it should be pointed out, they have a free tier, though like a business will blow past that pretty quick. Though it's pretty nice for a hobbyist. Okay. If there are, is that a, oh, I thought that was a question. I guess if there are no other questions, thank you for listening to me ramble on about GCP. I will make sure to send the slides and a copy of the code repository out to the meetup so that you can look through like what I actually did on the back end. It's just up on GitHub. But yeah, you can see what I did, what API calls I did, how I configured Cloud Build, that sort of thing. Thank you.
Thank you.